Letter A, I like to do it in kilojoules. You could have done it in joules, it's fine. Letter B has to be in joules because fancy R is in joules. Letter C, remember if it's endothermic heat, it's like a reactant. If I increase it, it would shift to the right. Products over reactants, my numerator gets bigger, so my K is going to get bigger. For letter D, everything is tied. The only difference is that little liquid to a gas would be a bigger change than a gas to a gas. Letter E is all the confusing words for crossover temperature. All the confusing words just mean that to set G equal to 0 and solve for temperature. That's pretty much what you need for chapter 19. If you could do that, you can do half the test for sure, because the other half is going to be 20. That's your voltaic cell and stuff. I would encourage you tonight to do the test review. The quiz corrections, although good practice, isn't always the best review for a test, because I don't write them. I just pick questions off of a program, you can tell. Things I write are very deliberate, and so I deliberately wrote that test review. I would do that tonight to make sure you got that all straight in your melon. No, that is just a warm-up. It was buff, actually, like I actually colored it.
Oh, I know.
You got it on Friday, but I think Friday you mostly worked on those quiz corrections. So that's that. The other piece of advice I have for you, like I said, we're like down to our last handful of lectures. And while we're not going to be learning new stuff, I'm going to be asking you to do more stuff. I have an AP book, review book that I wrote for you. It is 411 pages. And you will be required to do every single question on every single page. So that means, and we have work time, I'm not saying that, but that means that you're going to be spending a significant amount of time outside of class on chemistry that you haven't before. So it would be helpful if you could like check off the 19 and 20 box, you know what I mean? So you don't have to like go back like, oh, I still have to do my Form B, because things are just going to move quickly. We're going to learn 6 today, we're going to learn 7 on Friday, and then we have like a little half lecture, and then we're testing on it. Then we're going to learn 11 in a day, 12 in a day, 13 in a day, and have to test on that. So it'd be like, oh my God, we're learning chapter 13 and I still haven't learned 19. Do you know what I mean? Like, now is the time to like suck it up, buttercup, and stay caught up in your learning, because after that, then it's just like, here's the 20 pages you need to do tonight for AP chemistry. So, and you know, the whole purpose is to try to never have to do chemistry again. So it's going to be worth it when you get your score in July, but it does get intense. So I'm kind of like, keep up. All right, friends. And I say that because I am your friend and I don't want you to panic. For real, I don't. There are some days you're going to feel panicky. Just come to me and talk to me and I'll tell you you're more than a number. But we are going to learn chapter 6 today, so can you please get out your notes? They look like this. No, the number is a false ideal.
It's like the number helps me get into college. The number gets me money.
The number,
Yeah.
volunteering, being a good person.
That doesn't get you money.
Yeah.
Not for college.
Yes.
It does. That's just sad. Yeah, I know.
The ACT number gives you money. That I will confirm. But a grade point average does not give you money. Okay. I am so teaching you to a test. This is like very low quality teaching. This is because I get paid the big bucks to make you pass a test, and I'm just going to tell you the words you need to use to get the points, okay? I will explain it and all that, but please use these words. We're going to practice them. We're going to write them. They are the words to get the point, okay? So the first box of words, electrons are negative and are, that's a good R, and are attracted to the positive proton in the nucleus. Vocab word. This is called Coulombic attraction. I'm going to do vocab words in red. the radius of an atom. That should be one of your projects after the exam. Make t-shirts and sell them. That says I am a number.
Here's just make t-shirts for AP students.
Just like AP students. Hi.
I guess.
You always impress me.
Those are good skills.
I know, speaking of skills. Look it up. Wow. All right. Our brain eyeballs for this unit is a picture of an atom. This is not what an atom looks like at all, not at all. Just the same as equilibrium's not really like beakers of blue water, okay? This is just brain eyeballs. This is like a beaker of blue water for equilibrium. It's not what it is, but it's going to give us something to think about. Protons are positive, they're in the nucleus. Electrons are negative, they're in the electron cloud. The circles represent energy levels. Electrons are not in circles, energy levels are not circles. It just helps represent them. Okay, blue liquid and beakers. The radius, just like in math, for our brain eyeballs is like the center to the edge. Okay, so the radius of this one would be from the center to here because there's nothing out here. Even though there is there's actually 7 energy levels. This one only has 2 of them that have stuff in it, okay? The word for the attraction magnet from the protons to electrons is called Coulombic attraction. That's not the same as like positive ion, negative ion. That's lattice energy. This word Coulombic attraction is just strictly protons to electrons, okay? Our next words are over here, and I wrote them right off test, so I want to get them right. Electrons are further from the nucleus. With higher energy levels. Vocab. Lowercase n. When the music starts, please relate these 2 boxes to the brain eyeball picture. If all you can do is read it, that's fine. It'd be better if you could like summarize it and then compare it to the picture, but everybody has to have a turn. So like say it and then also listen to their turn. You're practicing the vocab words and you're practicing like the right thing to say. Okay, I know it's redundant, but this is how we learn. Ready? Go. Okay, what you were saying, all the things are right. Because the inferences you're making are all right. Like you're doing the right thing. Okay, the last box. The more protons that are in the nucleus, vocab, we call that Z as in zebra, effective. And the shortcut is Z. Z effective, effective nuclear charge, this shortcut is Z. The more protons in the nucleus, the higher the Coulombic attraction. Which was a vocab word. When music starts, talk about why. Ready? Go. I am randomly just picking 4 protons, just because that seems like a good amount to fit in a circle without being too squishy. I'm going to draw 3 energy levels, but I'm only going to put electrons in 2 to kind of make the point that they exist even though the electrons are currently living there. My first energy level can only hold a maximum of 2 electrons, so I'm just going to draw 2 blue negatives. I just drew 4 in my second energy level, a little bit random. And I'm going to draw none in my third, just to show that it's there, but nobody is currently living it. Remember, the vocab for energy level is a lowercase n. The vocab for the protons in the nucleus is Zeph. Positive protons, heart, negative electrons equals the word Coulombic attraction. Kind of putting it all together. Radius is from the center out. Just like in math, the radius is from the center out. Electrons can gain energy and move up energy levels from the vocab round state to an vocab excited state. The ground state is where they're starting. It's like their home base. But I can give them energy, I can burn them, I can plug them in. A firework would be an example of burning. Turning on a light would be an example of plugging it in. And the electrons are going to gain energy. So maybe this guy jumps up an energy level. Maybe it jumps up 4 energy levels. When they fall back down, to their ground state, vocab, they release the extra energy as light. Vocab, we call those photons. So they can't stay in excited state forever. They can't hang out in level 7 if they're in a level 2 electron. So when they fall back down, they just release it in something called light that we call a photon. Electrons are both a wave and a particle. That is called the dual nature of light. Electrons are not things. We draw them and talk about them like they're things, but they're not actual things. So they're both a wave and a particle because they're not actually a thing, they're just energy. So sometimes they act like a wave, but sometimes they act like a particle because they're neither and they're both all at the same. Okay? When the music starts, can you just practice these words? It's best if you can summarize it in like a couple sentences, but if you can't, just go ahead and read it so you're practicing the words. Make sure everybody gets a turn though. So you got to say it and then you got to listen. Ready, go. In my house, they don't. They really don't. Okay, put this on the list of memorizing. The order of EMR. Okay, EMR is just taking all of light. It stands for electromagnetic radiation. It's just taking all of light and putting it into categories based on its wavelength. So longer ones, shorter ones. Gamma rays are the shortest wavelength. The symbol for a wavelength is lambda. It looks like that. So the gamma rays have the shortest wavelength. They have the most energy. They're very damaging. They're really little and strong. All the way, X-rays, ultraviolet, visible, infrared, microwaves, radio. These have the longest wavelength, the radio waves. They have the least amount of energy, which is good because they're hitting you in the face right now, and you're fine. You're also getting hit with some ultraviolet. What'd you say?
I feel like that's how cancer's caused.
Cancer is ultraviolet. So,
Can't X-rays cause it too?
yeah, there's like this, like too much. Like it's a pretty big threshold. But the sunlight is the perfect wavelength to break up your DNA. That's what sun damage is. So like when you get sunburned, you're really just breaking up your DNA. It's not good. Only this teensy portion here our cones can see. So our cones can detect between 400 and 750. There is research out there that this isn't a hard number. So you might have good quality cones that can read a little bit lower than that or read a little bit higher than that. All of us can kind of see, when you look at a black light, you can kind of see, I know the light bulb itself is purple, but sometimes you can see a little bit glow. It's just maybe a smidgen under 400. And all of us I know can kind of see an infrared. That's that heat lamp. You can kind of see a red glow to it. But most of us see within this region. I know my dress looks black. I've been told that all day, but it's blue. And that's because, does it look blue to you?
Yeah, it looks
blue.
blue.
Okay.
It's gray. Yeah, blue and gray.
Okay, well, that's because it reflects light at about 480. So our cones register that at 480. It tells our brain to say the word blue connected to it, okay? A line spectrum, a spectrum is just like when we look through a spectroscope, you maybe remember on honors chem, it gives off a certain wavelength. A wavelength is just a color. It gives off a wavelength of about, I don't know, that one's 550 or something, because of electrons falling energy levels. Hydrogen only has one electron, so its one electron gets excited a lot. It can easily get excited. I believe this red line is from like getting excited to 6 and falling back to 2. Will always release this red one. This one I believe is a 4 to 1. So its one electron got excited, went up to 4 and 1. Every element is different. So we astronauts use these to see elements in space because every element's going to have its own. We have 2 math equations. You don't have to memorize these. These are in your equation sheet. Frequency is like a fancy kind of cursive V sort of thing. Equals lowercase c over wavelength. I'm using these letters on purpose because they're the ones that are on your equation sheet. Lowercase c is called the speed of light. It's a constant 3.0 times 10 to the 8th meters per second. Always going to be that no matter what. Your wavelength has to be in meters. So meters on top and meters on bottom cancel, which makes frequency a per second. Seconds to the -1 because it's on the bottom of the fraction. There's a guy, of course there's a guy. His name was Hertz, so he decided to, a per second is also a Hertz. Okay. The other equation, so we can calculate frequency. We can also calculate the energy of a photon. A photon is just the light given off. We can find the joules. We're going to take, this is a lowercase cursive h. It's called Planck's Constant. Planck was a guy, he was like a frenemy to Einstein. They were like competing, but they needed each other, so they like were frenemies. But he came up with Planck's Constant. It's a number. We're going to multiply it by that frequency to get the energy. Planck's constant is 6.626 times 10 to the -34th joules times second. It's also on your equation sheet. You don't. All right. A laser used in orthopedic spine surgery produces a radiation with a wavelength of 2.10 micrometers. I'm going to switch to red to do these conversion factors. 1 micrometer is 1.0 times 10 to the negative 6 meters. The other one you're going to see is a nanometer. A nanometer equals 1.0 times 10 to the negative 9 meters. Usually, you guys, they're written into the problem. You don't have to memorize them, but just so we have them here. So we need to convert that to meters. Calculate the frequency. So when we do our conversions, 2.10 micrometers over 1. Micro is like a backward U. Times 1. Micrometers on top means micrometers above. 1 micrometer is 1.0 times 10 to the negative 6 meters. So we're taking 2.1 times 1, basically. So it's 2.1 times 10 to the negative 6 meters. That was just the conversion, though, so we can actually calculate frequency. Frequency is that weird V, equals the speed of light, meters per second, over our wavelength in meters. It has to be meters, so it's going to cancel. Yeah, so push your buttons, because it's not about pushing buttons, it's about being active in your learning. .43 times 10 to the 14th. Make sure you're using parentheses if you're not using the E button. And the unit is S to the negative 1, because meters on top cancels meters on bottom. So calculate the energy of a photon with a wavelength of 589 nanometers. That has to be meters. Everything has to be meters. So 589 nanometers over 1 times 1. Nanometers on top means nanometers on bottom. 1 nanometer is 1.0 times 10 to the negative 9 meters. So 589 times 1 times 10 to the negative 9. Energy of a photon is Planck's times frequency, and we don't have frequency. So we're going to have to solve for frequency first. Frequency is the fancy V, equals the speed of light, meters per second, over the meters. Once we have the frequency, we can multiply it by Planck's, which is the 6.626 times 10 to the negative 3. Get that. Push your buttons, because it's not about pushing buttons, it's about being active in your learning. Energy of a photon equals Planck's 6.626 times 10 to the negative 34th joules times seconds times our frequency. We just solved for that. 5.09 times 10 to the 14th, and that was a per second. Push those buttons. You can just say what times Planck. Seconds cancels, and we are left with our friend Joule. Times 10 to the negative 19th is a teensy joule. It's just a little photon. So the wavelength tells us the color. So 589 is gonna be greenish, yellowish.
So is this like the intensity then, like how bright or not bright?
It's actually just the amount of energy it has, like when it hits you in the face.
Oh, so
Oh,
that
so
like
how hard
determines.
it's your face.
Yeah, which is like nothing, which is
Yeah.
good because we don't want my blue to hurt your face.
Yeah.
Can you get out your bowl packet while you just quick see if you remember the order of EMR? And if you don't, read it to somebody like twice in a row. You have to know like smallest to biggest.
We should make up what is it?
There's acronyms out there. I don't know what they are. Yeah, it has Plancks on there. It has everything. So you don't need to.
Wait,
Where-
how's the difference be a light ray sound?
I think it says 2.998, but it's the same thing as like 3.0 times 10 to the 8.
Okay, yeah.
Okay. So take it off your worrying about list because I'm pretty sure you can push a button.
Yeah.
All right. Wave function. A wave function is a math equation that solves for the probability, like stats, sorry if that's triggering to anybody, probability of finding, because I know this too, finding an electron. There was some calorimetry on there.
Yeah, they
I
just
saw
said-
this.
Do you feel good about it?
I felt really good.
He's like, Sam, what
Yeah,
was
it's
the- wait, what was
Wasn't it NaOH and HCl? That's
Is that
exothermic.
exothermic?
Yeah.
That's exothermic?
Haley and I both decided it was endo.
It's
I am-
not.
I didn't read the question. I just,
You just have to say, is it exothermic or endothermic based on like.
did it release energy, get hotter or colder?
Yes.
Hotter is exothermic.
Yeah.
Who said endothermic?
Apparently. Okay, wait, look at this one.
Okay.
Wait, look at this one.
That's exothermic.
Yeah, because it starts as lower and then goes up to a higher temperature.
Final minus initial. Chapter 5. All right.
I don't know. I don't know. I don't care.
Okay. This graph is going to be our radius on the x-axis and our probability on the y. So there actually is, like you could take a class if you wanted to on quantum mechanics and you would learn this math equation if you wanted to. But what it does is they plug in like the charge of an electron, they plug in like the charge of a proton, and what are the chances the electrons are certain places, okay? So radius of 0 means it's like right on the middle, because radius is how far out from the middle. So at n equals 1, so that's the first energy level, the highest probability is that it's really close to the center, and that's what we drew. We drew our first energy level closest to the center. N equals 2, highest probability is it's a little bit further out, so we drew our level 2 a little bit further out. N equals 3, the high, which is still low probability. So probability of 1 is like 100%. This is like a probability of 0.06. But that's the highest we have, is way further out. Probability just means what are the chances, okay? So, because the electrons aren't things and we don't really know. This is just math. We could also plot those points. This just shows that this is n equals 1, the first energy level, is probably really close to the center. Is there a chance that it's way out? Yeah, there's always a chance. Yes.
Why are there like bumps?
Because these are called nodes. Nodes are based on math that there's a 0% chance that the electron is right here. But there's a little smidgens of a chance that it's a little bit closer. There's a little smidgens of a chance that it's a little bit closer, but probably it's going to be furthest out. It's these lonely guys out here are these, those are those out there, okay? All right, some guy, probably an old white dead guy, decided that you needed to know where every electron probably was in every atom.
Yeah, this was the SP.
Yeah, this is called
Yeah, the like, I thought this
1s2, 2s2. This is called the electron configuration. They decided that you need to know where probably every electron was in every atom. The thing about it is like atoms or electrons aren't things and you really don't know where they are. But It thankfully creates a pattern on the periodic table, and also thankfully that as long as you can count to like 110-ish, which I'm fairly certain you can, this will all work out for you. What it is it's a pattern to where the electron probably is. Every single electron in every single atom. So the pattern is this. This row is the first energy level. This row is the second, third, fourth, fifth, sixth, seventh. But they are also categorized by a shape. This shape is just like if you had a fancy calculator and you plugged in y equals the wave function, that math equation, you'll get a graph that looks like this. The s orbital graph would look like this. It's just like a y equals on a fancy calculator, okay? Helium's over here. Scooch is over there. So that helium is actually over here. The next shape is called the p orbital, and it has more energy than the s orbital, so it doesn't even start till level 2. Level 2, level 3, level 4, level 5, level 6, and level 7. If we plug that wave function into a fancy y equals calculator for a p orbital, we get these 3 shapes here. These are called orientations. It's just different directions of the same shape. Each orientation can hold 2 electrons, so 2, 4, 6 electrons total, and there's 6 boxes in the P, all a pattern. D is next. D doesn't start till energy level 3. It has more energy than P and S. This is called the d orbital. If we plugged it into our fancy y equals calculator, we get the rest of those shapes. And the f orbital is down here, 4 and 5. It's called the f orbital. Okay? The thing about saying where every single electron is in every single atom is we have to do a lot of counting. So a lot of counting means you have to at least be able to count to 110. Okay? By counting, I mean like actually counting. Just because we have to pay attention to this section here. So cesium is number 55, barium is number 56, lanthanum is number 57. But oh no! The next box is 72. 72 does not come after 57. What comes after 57? Just tell me a number. What number is next? 58 down here. Okay, so you just got to pay attention to your counting. 58, 59, 58, 59, 60. I would not pass kindergarten. 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. Oh no! It's okay, 72 is right here. Okay? So you just have to find the numbers in order. So if we were going to write an electron configuration for hydrogen, what we do is we find hydrogen on the periodic table. It is in the first energy level, so we write a 1. It's in the S shape as well. Yes. So we write an S, and it's the first one over, so we write a 1. Helium is also in the first energy level. It's in the S category, but it's the second one over. Somebody decided we should need a shortcut. I vote it was a woman. What we do is we go to the noble gas before it. Again, counting. 18 is before. So we're gonna. Do you want me to do it or do you want to go?
Do it.
Okay. After 18 is number 19. 4. Still in the S. There's 2 of them before I have to switch categories. Now I'm in the 3. D. So I got to start over. 3D. Now I'm counting. 1, 2, 3, 4, 5. 3D 5. We'll sit. Your homework is to study, but the day after that, your homework is to do the first piece of paper in the worksheet. Do your test review tonight, though, okay?